episode where we're creating a MUD game using Swift and NIO, and in this episode we're going to add sessions to our little game. This will allow the player to log in and then perform actions from a logged in state. So let's dive right in. So we already created this session handler, channel handler, and this one right now just creates a new session for a player each time a message comes in. The effect of this is that each time a player enters a new command, a new session will be created, as if the last one was forgotten. So I think what we want to do is be sure that we're able to read these sessions from somewhere else, or just keep a list of them somewhere and see whether a user already has a session, or if not, then we will create a new one. To make at least testing a bit easier, the first thing we're going to do is we're going to start with allowing the player to log in. This way we can be sure that we have a quick way of testing to see whether we can get the correct type of session or not. And fortunately we already have the verb and a command to create users. We'll add a new one, and this will allow a player to log in using a username and a password. And as with the create user, also this one will expect 3 words in the sentence. So it will say login and then the username and then the password. And similar to a create user, will return here the new value. We'll assume that the first word in the sentence or the second word in the sentence is the username and the third one is the password. And this one does not need that many right-hand brackets. And let's see, and one more of those, and this should now be okay. Our user should also have a login function. So we'll have a static function login, and this too will to get a username and a password. It will be an asynchronous function, and it can throw, and it might return a user if you're successfully logging in. So the first thing we should do is we should make sure that we're getting a user from the username. So we should be make sure that we're actually having a user. So let's say we'll let a user equals user dot first, and we'll search for the username. Else we'll send back an error. We'll call it user not found. So we'll throw user error, user not found. At this time, user will be, let's see, we should await here. So now user, by the time we're getting here, is a complete user, and this user has a hash password, and we need some way of verifying the hash password compared to the password. And we can't do it directly. We can't say something like user.hashPassword equals password, because this password is in plain text and this is a hashed value. What we'll do is we'll create a verify function in our hasher, and this one will receive a password and a hashed password, and it will return a boolean, and we'll just rehash the password that was sent in, and if everything's going correctly, it should be the same as the hashed password that was sent in and will be of type string. So this will be the hashed password. And if this is these are the same, then this will return a true value, and we know that the password is correct. So what we'll do is we'll guard to see whether hasher.verify, and we'll send in the password, and the hashed user had a hash password. What we'll also do is when we were creating the user, we were adding the username to the password. So we need to do this as a sort of salt. We need to do the same here. If that doesn't work, then we'll send them back another error, a password is mesh error. If this goes correctly as well, then we can return the user, because now we found the user, we verified the password, then we can send back. Actually, because this is a throwing function that throws if this is unsuccessful, we might as well just send back a user, because by the time it's sending something back, it's no longer an optional. So now we have a function that helps us log in. Let's see, I think we need to add this case also to the parse handler. So we have a case for that we get a login in. We'll get the username and the password associated values. And we'll wrap this in a try block, because we're going to use some throwing assumptions. So let's try and get the user. Let's call an existing user, and this will be a try await user.login with the username and the password. Then we can update the session with the player ID, because now we have an existing user that has an ID. And we can send a response back. Let's just copy this one. We'll say welcome. Welcome back. Existing user.username. Let's get rid of this one. If this for some reason fails, then we'll echo back at least the error message. Let's copy paste from here. Error logging in user error. This might be enough to at least get this working. So let's see, it's building. We will have and while we're waiting for it to start up. Okay. So now we should be able to log in using, I think these were existing passwords. So that's working. We can also say login full and something else. This will give the password mismatch error back, or we can say login a full, and that user is not found. So now we have the ability to log in. What we don't have is, and I think the easiest way to show this is to add the user ID. Let's see, this makes the text green. We have a response message. For debugging purposes, we're going to add the response session.id, and we'll add the response session.player ID. And we'll put this in, make it a bit easier to see. So this is just a bit of debugging. So we have a session ID and we have a player ID. Let's try restarting it. So now if we log in, it will say, hey, you have a session ID and you have a player ID. Very nice. However, if you enter another command, something like a command that doesn't exist, we notice that the session ID changed and the player ID is now gone. And the reason for that is that the session handler for each incoming command creates a new session. So we have the ability to log in, but we don't yet have a way of persisting the sessions. Now what we would like to do is have some place where we can store the sessions, something like a session storage, and ideally we would just have something like a static var called sessions equal to an array of sessions. This is a really quick and dirty way of getting a static value where we can simply add and remove sessions. The problem with this is that it's not thread safe, and we are creating a multi-threaded application. It's not thread safe because the standard array in Swift by itself is not thread safe. So we need a bit more boilerplate code to get this working the way we want. Feel free to try it without. Feel free to just try it this way. You might run into strange errors or unexpected behavior. You might even not notice anything if you're just locally testing. But when you start have multiple connections and multiple people working without any additional guards to make sure that this is thread safe, you will run into errors and lots of unexpected behavior, and these tend to be some of the most difficult things to debug available. What we need is a lock. Well, there are like everything in programming, multiple ways of solving the same issue. So basically you want to make a thread safe version of the session storage. I'm using logs here because it's fast and simple. You might even use an actor like we did here with the AwesomeDB. You could use an actor here as well. That will make it thread safe. The downside is that it will mandate almost all interactions with your session storage to be asynchronous. And this really isn't an I/O bound operation because we're not persisting these sessions to disk or anything. So we really don't need asynchronicity here. So we want to keep it synchronous and as simple as possible. To protect these variables from outside, we're making them private, and that means that we now need some functions to interact with the session storage. And the first one we'll need is, we'll replace or store a session. And let's add sync to it so we understand it's asynchronous, and it will simply take a new session. And all this really does is we're first going to set a lock, and very importantly we also unlock it. And as long as we're making sure that the code between these two statements always ends or always is able to run, there's not really that much of a risk for deadlocks here. Let's first see if we have an existing session. I will take the first index where the session ID equals our new session.id, and if it does, then we'll say sessions existing session index will be updated by the new session, else we'll simply append the new session. So now we're able to replace or store new sessions. We also need to be able to get sessions back from it. I think we'll just implement a first method where we'll simply say looking for a specific how do we want to search for sessions? Using an ID or player ID, or let's keep it a bit more generic for now. We'll just accept a predicate that is a function of the type. It takes a session in and it returns a bool. I'm using this signature including the throwing because that's the same as most of the other collections, and we're really creating a collection here. So we have a first where and we might return a session, so we'll return an optional. Then what we do is we have a result and we'll try and find the first session where the predicate matches, and return the session, the result, which is an optional of type session. This code is not thread safe because we might be trying to read while we're updating the sessions array, and we also might try and start updating while we're still reading, and that can lead to unexpected behavior. So here again we will lock and unlock. This isn't the best possible solution because this also locks for all sorts of concurrent locks, and or will also lock while we're only doing concurrent reads, and concurrent reads should be thread safe. There are more elegant ways of solving that situation where you only need a lock while you're trying to update, and only try and update while nothing is reading. That's way too complex for this series, and also the performance overhead here, considering these type of statements which are so fast, doesn't really matter. So let's see. So we now have a way of storing and getting back sessions. Let's update our session code here a bit. Let's say we have a session, and instead of using getting a new one, let's try and retrieve the one from our session storage. So we have a session storage first, and we'll look for the one where the channel, and I think you need the remote address equals the context channel remote address. So we will match them based on the remote address. And this might return a session, and what we'll do is, if none can be found, then we'll use a new one as the default value. So session will either be set using the first method if that returns an actual session, or it will return a new one. So now we have a way of keeping our sessions the same. Let's see if this works. So our server started. Let's log in. So we'll again log in, and let's see. So we have a player ID and we have a session ID, And let's send another command. We're still getting back different sessions because we're not storing the session. So we should also make sure that we're actually storing the session. So that's the first. That should help. It's probably not going to work exactly as we expect yet, but it'll be better. So we now have we have a session ID and player ID. Let's try some other command. We also now retain the session ID, but we're forgetting the player ID. And that's because we're only storing the session once, and at this time it might not yet have a player ID. So what I'm going to do is I'm going to take the response handler or the parse. What's the best place to do this? Doesn't matter that much, I think. Oh, we're also closing sessions here. I think this would be a great place to simply update the session. Let's see if this change and this works. So we get our optional with the player ID back. Let's try another command, and now these are remembered. Let's remember this session ID, so it's 907, etc., etc. I'm not sure. We're getting a new session. I think one problem is we're not really cleaning up the session when we're closing this session. So I think we need one additional method here. So we'll create a delete session. This too needs to lock and unlock. And we'll say if let the existing session index. I think it might be easier even. Let's see if sessions remove first. I need now we need an index. No problem. Let's existing session index. The session ID matches the one from the one coming in. And remove at. Let's get a bit of debugging code to make sure that we're actually deleting it. Okay, let's try and run this one. So we have our session ID and our player ID. We close. We're saying goodbye, and I don't think we're calling the delete method yet. So we're closing this session here. We should also say session storage delete session response.session. Make it a bit larger. Okay, so we're logged in. We'll close. So, and now we successfully deleted this session. Cool. think that's enough to meet today's goal. So we are able to create sessions, associate players with sessions, and we allow players to log in. And next time we'll start working on rooms, because then we can really start making it a game instead of just a piece of framework. It's now that allows you to create a user and log in. Thanks for watching and have a good day.